Hello, Pine Hollow pilots. This is Mr. O with your next set of flip notes. This is going to be on standard 6P13, which is the technical term for sound. All right, with flip notes, keep in mind you have these four valuable tools. You have the power to pause the video at any time to help you collect your notes. You can rewind if something is not clear to you, you don't understand it. If that doesn't help and you still are confused, please write down that question and I'll be happy to answer that when we get back together. And number 4, you can always refer back to these when completing assignments this week. There are 2 options for note collection. I left you a document in the same assignment in Google Classroom. It's called the note template, and you can copy that in electronically as you go. Or you can go old school and write on a piece of paper as you go. Either way, taking notes are not optional. Even though these are not graded, all the grades from this week will come from these notes. So it is very important to get this information down. All right, well, let's get started. We are talking about sound. Okay, so as you fill out your notes, if you're using my template or filling out your notes, they will go in order. Technically, what's defined sound? It's a wave that is produced by vibrations in a medium. If you do not remember, a medium is any type of matter, solid, liquid, gas, and that it will travel through matter in all directions. So if you think about it, if you make a sound, the sound does not just go straight in front of you, it spreads out in all directions. This is why you can hear me if you're standing behind me and I'm talking. It's proof that sound goes in all directions. Okay. Now let's talk about sound waves in general, and this is kind of a review of what we did before we tracked out. The type of wave is mechanical because it needs a medium where it needs matter to work. And the type of wave movement is longitudinal and compressional. I left a picture down there just to remind you what that movement looks like. Now, how are sound waves produced? Sound waves are produced, and the word produce means to make. A vibrating object pushes and pulls on the medium and sends waves in all directions. I have a picture here that shows it pretty well. There's the object that's vibrating. That could be anything from someone's voice to a musical instrument to a phone. And the atoms in the air are pushed and pulled as they get to your ear, and that's how you hear things that are making sounds. The next is how particles move as energy is transferred through a sound wave. And this is really getting technical about what compressions and rarefactions are. They move in the direction of the disturbance. Remember, transverse waves move up and down, up and down, up and down. However, longitudinal waves move with the direction of the energy. And then you see the compressions is where the atoms get bunched up, and the rarefactions are where they get spread apart. And they cycle over and over again. So you can see that cycle from that speaker in the picture to the person's ear. Let's talk about how the vocal cords work, because this is how you make noise. Okay, there's 3 steps to this. They're pretty simple. First, air is pushed up from your lungs. This force of air causes the vocal cords in your neck or throat to vibrate, and then these vibrating vocal cords produce sound waves. Now, don't get me wrong. You learn to make words with your tongue and your mouth, but the actual sounds that are starting to be made from your body happen in your throat with the vocal cords. We're going to move on to the ear. Now, in your, if you use my copy, I have a table that says part or section, part, and purpose. Okay. So this is a generalization. There's a lot more parts to the ear than I'm covering, but in 6th grade, this is the parts they want you to know. And the first section would be known as the outer ear, and you can remember that because it's on the outside of your head. And that part has 3 things that you need to know in 6th grade. It's called the ear canal, and the eardrum. And that goes in order. The outside ear is what you feel. The ear canal is the hole, like if you clean your ears with toothpicks, you put them in your ear canal. And the eardrum would be the ending of the outer ear and the beginning of the middle ear. And the general purpose of the outer ear is just to catch sound waves. There's a reason why your ears are the shape they are. They're built to catch sound waves and bring them into your head. That's why they're designed in that shape. That's why they stick out from your head. It's why they're all curved and they angle towards the hole. The second section is known as the middle ear. Now, don't get me wrong, these sections are pretty general. middle, outer, inner. The middle ear is made up of three little bones. They're the three smallest bones in your body, and they are in order: hammer, anvil, and stirrup. If you know what a hammer, anvil, and stirrup look like, they actually mimic what the bones look like. But the general purpose is to take sounds from the outer ear and send them to the inner ear. The middle ear doesn't have much more purpose than just that. They are like the tunnel for the outer to the inner. It just so happens that they go through these bones. And the last section that you need to learn in 6th grade is called the inner ear. And these are the two, in my opinion, are the most valuable parts. The cochlea, which looks like a seashell type thing, and an auditory nerve, which means it will send the auditory signals to your brain. Okay, the cochlea, if you look in the, I'll show you the picture in a minute, they have these little hairs that stand up. These little hairs can figure out what sound you're hearing, excuse me, and they interpret those sounds, and then they push them to the auditory nerve, where the auditory nerve will send them to your brain saying, oh, I hear the fire alarm going off, I must stand up and go outside. So the inner ear is the part that its purpose is to interpret sound waves and then send them to the brain. Here's a picture of the ear. We'll talk more about this in class, but the outer ear is just generally the ear you think of. And then the two other parts, the middle and the inner ear, are you can see the different sections in there. It looks like the eardrum is part of the middle ear, even though it really isn't. It does look pretty close. And then the echelon tube is the drainage tube that goes into your throat. This is sometimes when you get a cold, you'll get a cold and you'll get an earache because your ears, nose, and throats are all connected, and the Eustachian tube is what connects them. So a couple of different things in the ear. We'll get more into that in class. Let's talk about how we hear sound. Sound waves cause the eardrums to vibrate, okay? And these vibrations travel through the three bones to the middle ear, to the inner ear, and these vibrations travel through the cochlea to the auditory nerve and send messages to the brain. This is just a quick review of these different things of what we just talked about with the ear. Now, there's kind of cool things when it comes to sound, and sound has an effect on two different things. The first is the effect on a material. And then that means the denser the material, the faster sound will travel. So if you look at my little diagram, I gave you a picture of what a solid, liquid, and gas is. And in those pictures, I have these little smiley faces, and those little smiley faces would represent atoms. And we'll talk more about that when we get to matter. But remember, sound wave is mechanical, meaning it has to hit matter to move forward. So the faster it can hit matter, the faster it will travel. So if you look at a solid, there's all these different things it can hit. But if you look at a gas, not too many things it can hit. So the denser the material, the faster it will travel. But keep in mind, there's a remember statement on the bottom of this. Speed does not mean how well you hear something. Because if you look at the diagram, you should be able to, you'll hear sound faster underwater than you would in the air. But it's super hard to understand things underwater. So keep that in mind. So sound is affected by the material. It's also affected by the temperature. Now, the same rules apply here. Okay, remember, sound has to hit matter or atoms to move forward. In hot temperatures, atoms are moving really fast, and in cold temperatures, they're moving very slowly. So the higher the temperature, the faster it travels, because the more likely the sound will hit an atom to move forward. And I said that here, increasing temperatures allow the atoms to move faster and allowing sound to hit them quicker. And you think about cold, that will move slower, which decreases the chances of them getting hit as fast, which slows it down slightly. And we're on to the final two things here. Pitch and frequency. Okay, pitch is a thing that's dealing with just sound. Pitch, by definition, is how high or low a sound wave is. And pitch is determined by frequency. Okay, higher frequency, higher pitch, lower frequency, lower pitch. And even though that sound is a longitudinal wave movement, they use a transverse wave movement to measure frequency and pitch in a scientific tool to do so. And if you don't know the difference between a high-pitched noise and a low-pitched noise, just think about a kindergartner on the playground screaming, and then think of an adult screaming. The pitch of the kindergartner will be much higher, and that means their frequency is higher, and then the pitch of the adult will be much lower. It's because the frequency is much lower. We'll talk more about that if you have any questions on that part. But we'll talk more about that a little bit in an activity later in the week. And the last slide we're going to talk about, when it comes to sound waves, we talk about intensity, and that means amplitude. If you remember what amplitude means, that means energy of the wave. Intensity means the amount of a sound wave has, the energy a sound wave has. Intense sounds can cause hearing damage, and most hearing loss issues are found with problems in the cochlea. We'll talk more about that in an activity later in the week. Remember, I talked to you about cochlea having those little hairs, and those little hairs can be damaged and placed down. But we'll get more into hearing loss issues in a later activity. Other than that, I hope all is well. If you have any questions for me, please write them down and ask them when we get back together in class.